Hello, everyone. Let me start that over again. Hello, everyone out there in podcast world. Hope you're having a wonderful day. Here we are live on a Friday afternoon, and I'm talking to Steve Rogers, and we're going to talk about the Energy Conservatory and how it's beneficial to you as a business owner. And I was honored to be able to hang out and meet and hang out with Steve over it's been a couple weeks ago now at the HVAC School Conference Symposium down in Florida, Orlando, at Brian Orr's at Kalos. And it was amazing to listen to Steve talk. And a lot of what Steve talked about was way over my head stuff, but it was really cool. And then like Joel Becker and those guys, we were having conversations of how beneficial the products that the Energy Conservatory offers. And Steve was talking to me also about like we can use these things and not only just generate more money with a different revenue stream, but provide happier clients in the process, because we are actually doing a much better service for them as a company. And so I was like, you know what?
Yeah, well, I'm happy to be here.
I think you should come on the show. I think it'd be very beneficial. And he was like, I'll do it. And I was like, sweet. So here we are, Steve. I do appreciate you coming on the show.
Yeah. Interesting. You mentioned Joel, because he's a geek's geek, but he also has a really good head for business. You can tell that he's thinking about the sales process and how can this make sure that once we get to the install, that it's going to go more smoothly and avoid callbacks and, all that stuff that is wrapped up in the whole business.
It really, and like whenever I talk to Joel, because we're like in this group chat, and I talk to him and I interact with him, and I'm like, all right, yeah, he definitely knows like airflow. He knows all these BT, like he just knows it all. And so like I just didn't expect him to say, oh yeah, and the business side, this is what you do to here. No. I was like, Joel, you're surprising me, dude. This is cool. I like it.
Yeah.
So tell us a little bit, for those who are listening to or watching this, tell us a little bit about you, your background, and how you became involved with the Energy Conservatory.
Okay. So my background is I went to school to become a mechanical engineer, and like all mechanical engineers, I wanted to design stuff, and that's not really how my career ever went. I did do a little bit of design along the way, but I ended up working at Emerson for not the Emerson that's in HVAC, a different division of the same company, for about 19 years doing pressure and flow measurement related stuff. And so that's where I cut my teeth. That's where my expertise comes from, is many years doing that sort of thing. Then I went to work for Dwyer Instruments for about a year, good company, interesting stuff that they do. But we moved the family to Indiana, and it really didn't work out for my kids. And so we were looking for something coming back. And that's how I found the Energy Conservatory. They brought me on board doing engineering and operations management. And then a couple of years later, I bought the company from Gary Nelson, the original owner. And that's kind of what got me involved with HVAC. So I've done pressure and flow measurement for a really long time, but really HVAC specifically only for about 5.5 years. So, but what I'm finding is that a lot of what I know is directly applicable. And of course, there's lots of stuff that I'm still learning, refrigeration details and stuff like that. So, if I were to say, what is Energy Conservatory all about to an HVAC business owner, I would say we're about understanding the air side and the building. I think generally HVAC companies you have to have some pretty good understanding of the equipment itself, but as the problems get harder to solve and more complicated, it's less often going to be a problem with the equipment, and maybe it's more often going to be the ductwork that's attached to the equipment is the problem, or it's the building that's causing the problem. And that's where we come in, is helping to understand the root of the problem by looking at anything from air tightness of the building to building pressures when you turn the equipment off and on. What pressures is that inducing, to duct leakage. And then, most recently, we've got a new product that makes it super simple to measure the system airflow.
Well, that's something that I was fascinated with whenever we were at the HVAC school symposium, because I was like, man, this is almost too easy to use. You know what I mean? And it's so often here. I know there's a lot of other places that they're amazing with their ductwork, and they don't have any problems with sizing ductwork or anything like that. But here, it feel like it's if you're doing good, you have a metal trunk line, and then you have just some flex taken off of it, and you're just hoping for the best. Everybody's getting a 6 or maybe even a 5-inch flex to a bedroom, and it doesn't matter how long the run is. It's just everybody's getting the, you know what I mean? And so it's like you go somewhere and the problem, it won't dehumidify, it won't cool the house down during the summer, and so let's just throw another box in here. And in reality, it's just really garbage ductwork. And you cannot, a lot of people don't understand this whenever they're putting in a new system, and let's throw an XV on there, a variable speed inverter condenser with a variable speed blower motor, and that's going to solve all our problems. Well, you put a variable speed motor on something that runs at 1-inch static all the time, and you're expecting energy savings, and that's just not going to happen. I mean, that's your electric bill can shoot through the roof with that aspect.
Yeah. Well, and then, if the problem is humidity and you think an inverter is going to solve it, I mean, it's becoming pretty clear that inverter systems, anytime they're less than maximum speed, the dehumidification starts to go out the window. Mm-hmm. And so you got to know what you're doing with the equipment. You got to get it sized properly, even when it's an inverter. And you got to know.
So what you're telling me is that I can't just so they have a 3.5 ton there, and I can't just throw a 5-ton inverter on there and just let it ramp back down and run.
Well, it depends on what your objective is. If you want you want the house to rot, that might work.
Right. Go ahead.
So there's no silver bullet. I mean, I think that of all the trades that I'm familiar with, and I've kind of done a little bit of work in many of the different trades. I've done home building and electrical and plumbing and HVAC on my own. I by no means understand it all, but I think HVAC is by far the most complicated trade. You have to be a little bit of an electrician. You have to be a little bit of a plumber. And then you got to understand all this stuff about airflow that nobody understands.
Right.
And,
that's true.
And so, the better we can make the tools to help people understand what's going on, so much the better. So,
tell me a little bit about some of the tools that you have that we can use to make this just smoother process for our guys in the field.
Yeah. So I'll start out with what we're most known for, and that's the Minneapolis blower door and the Minneapolis duct blaster. And most people by now know what a blower door is and what a duct blaster is. But, really, if I think about being a business owner in HVAC, it's a pretty big leap to say, you really ought to have a blower door. And that's where I think this new product that we've come out with makes it is a more directly applicable step for a business owner to say, you know what? Some pretty significant portion of your problems are airflow related. Mm-hmm. And we know that's hard to measure, especially on older equipment. And so this true flow airflow meter, you can just put it in place of the filter and it'll tell you, so we do a static pressure diagnostic, like, if you're familiar with what NCI does with static pressure, we do that plus flow. And now if we know the static pressures and the flows, we can give some really valuable information. We can tell you, okay, you're at like 200 CFM per ton, you got an airflow problem. And we can tell you, okay, by looking at the pressure drops, we can pinpoint, it looks like the problem is your return is undersized, or maybe you got a big restriction on your supply because somebody went up in the attic and they knelt on a couple of the ducts. Or maybe you've just got a really dirty evaporator coil that needs cleaning. And just measuring those pressures, we can give you that feedback immediately and say, here's what you ought to look at.
So are you using, we can't measure static pressure with that tool, correct?
No. So
Okay.
the new DG8 manometer, you've probably seen the single channel.
I remember seeing that.
Yeah, that goes with it. So it comes as a kit. You can buy either piece or the two pieces together as a kit. But if you buy the whole kit, then you do the static pressure and the flow all together, and get the best information that you can get. The nice thing about the manometer is, if you start looking at the air side and building diagnostics, you realize that, we really need to understand if we're pressurizing the master suite. We see lots of stuff posted on Facebook lately about how, they're pressurizing the master suite to 10 pascals, and that's causing big comfort problems. And if you don't understand what that means, this is something you really need to learn about, especially in your region where you guys are at, Tersh. Yeah. Pressurizing rooms is a big problem.
So explain to those who are listening what that will actually happen.
Okay. So what happens if you're pressurizing rooms is there's, say you got a master suite and it's got, 2 supply registers in the bedroom and another one in the bathroom, but there's no return in the master suite. So when you shut the door between the master suite and the rest of the home, there's a huge pressure resistance. There's a huge resistance to the flow, which means that the bedroom's going to get pressurized and the rest of the house is going to get depressurized. And that causes a couple problems. The most significant one is that comfort might be fine when the bedroom door's open, and then when they close the door at night, now the airflow's gone way down because there's this extra resistance, and it's also causing more infiltration in the house.
Because the rest of the house is under negative pressure.
Yep, the rest of the house is under negative pressure. It's sucking in from outside, and in that master suite, which is positive pressure, you're actually blowing your conditioned air out through all the cracks in the building.
So, in theory, though, we want a positively pressured house, correct, or at least neutrally pressured, because we don't want the whole house negatively pressured even a little bit, right?
Especially in your region, negative pressure in the humid South is probably worse than positive pressure. But the reality is that you almost never achieve either one. Unless you build a building really tight, and that's not the norm.
And then control it with like an ERV or something.
Yeah, unless that happens, you are going to get the usual stack effect, which means in the cooling season, it's like let's start in the heating season. In the heating season, it's like your building is warmer than the air outside, so it kind of acts like a hot air balloon. The air wants to float up because it's less dense inside and it's denser outside. And so what that means is that you get negative pressure at the bottom of the building and positive pressure at the top of the building. And then somewhere in the middle is this neutral plane where there's actually no pressure difference. And then in the cooling season, it's reversed. You get negative pressure at the top of the building and positive pressure at the bottom. So you're actually sucking in from the attic during the cooling season,
which is the hottest place in our area.
Yeah.
Because that's like I've gotten in attics before where I literally have gotten a 2nd-degree burn on my hand from touching the AC unit. So, yeah. And then Christopher Hughes, he was with us at the Animal House there in Orlando. He was asking, he said to have you ask about a tubing assistant on a DG1000.
Yeah. So this is moving from this new product to the blower door system. So we find that lots of people who do take that next step and they really want to learn about blower doors and about how to do a duct blaster test and stuff like that. One of the things that's tricky is figuring out how do I set up the tubing. Because if you're pressurizing versus depressurizing, and if you have the gauge inside the building versus outside the building, the tubing's all a little different. And so we put together this tubing assistant where it just tells you, okay, are we pressurizing or depressurizing? Are we standing inside the building or outside the building? And then it tells you, where all the tubing goes. So, okay, put the green one on this tap, and that one goes to outside, and the red one on that tap, and that goes to the fan. It just simplifies the whole thing, and it makes sure that no matter how complicated a situation you're in, you're going to get it right.
Cool. So do you
For
feel
people who
like,
do, go ahead.
go ahead. No, go ahead. Because I'm going to
Yeah.
change the subject. So
So the standard blower door test, you can kind of remember how the tubing goes, but if you start doing something a little different, like if you're blower door testing apartments, which for a number of our customers do, you usually are standing outside. You get your gauge outside the apartment. You're in the, on the walk up apartment, or you're in a hallway if it's a common entry apartment, and then your tubing gets a little twisted around. You got to remember how to do it. And so, all these different cases that you might not do very often, that's it's helping you figure it out.
Okay, cool. So we're talking a lot about, we're talking a little bit here about your blower door test and then your duct blasting. If you're an HVAC guy, so you own an HVAC business like me, and it's not mandatory to do duct blasting here. It's not mandatory. You don't have to do any kind of blower door test or anything like that. At what point would you say a business owner, it's a smart move to get into blower door testing or duct blasting, or should you just wait until something like that's mandatory, or wait until you're just into the home performance thing, or what's your feedback on that?
I can't say exactly, but I can give you some clues. So one of the clues is get a good blower door style manometer and start measuring building pressures, because you're going to find out that there's certain cases where you're unable to solve a humidity problem because there's duct leakage to outside. And you can get some pretty good clues without even taking that leap to a blower door, just by measuring the building pressure. And what I mean by that is you just take, if you have a good accurate blower door style manometer, like our new single channel, lower cost one, run the tube out the door, close the door, measure the pressure. It's going to read a little bit of pressure because of the temperature difference inside to out. Now turn the equipment on. And if you see the pressure between indoors and outdoors changing by 2, 3, 4 pascals, that's telling you've got a lot of leakage from your ductwork to outside. It could be on the supply side or the return side, but that causes big comfort problems because that's not accounted for when you do your load calculations. Manual J assumes that you have the duct leakage is in balance and it's not pressurizing or depressurizing the house.
Yeah.
And when you start doing that, you can double and triple your infiltration load easy.
Oh yeah, absolutely. I 100% agree with that. What manometer was that you mentioned?
Yeah, the DG8 manometer
is DG8. Okay.
Yeah, our new single channel blower door style manometer, and it's really specifically to help people take these steps towards a blower door. When you get to a blower door, I'd say once you've encountered a number of these problems that you can't figure out how to solve, you need to start looking at a blower door, because this is going to tell you exactly how leaky is it, and with an infrared thermometer, going to start helping you find exactly where those leaks are, and it starts to become really apparent whether the problem is the equipment or the ductwork or the house itself.
Now, do you feel like a blower door test should be performed prior to system replacement every time?
No, I think it would. It depends on what you're finding. You got to follow the symptoms, and I don't think the blower door test is the first thing, but it's certainly, depending on how far you're going down that diagnostic path, there's you should get there before too long. And it might be that before you get a blower door, you need a buddy with a blower door.
Yeah.
just like a pickup truck or a swimming pool. You don't need a pickup truck or a swimming pool. You need a buddy with one.
Yeah. The DG1000, can it be used with any with the existing blower door? Julian asked that.
Yeah. So the DG1000 is our new manometer, and it's compatible with all of our blower doors and blower doors and duct blasters we've been selling for years. It works with the old legacy TrueFlow. It works with the new TrueFlow. So it's kind of the universal for all our products.
What about for other brands? Because he happens to have one that he inherited, I guess.
Yeah, we have decided not to make it work with other brands because it's a significant effort. But the other thing you have to think about is
makes sense.
If you got mixed brands, right?
Yep. The
Now
accuracy and everything.
I got a problem with this blower door test. Is there something wrong with my fan, or is there something wrong with my manometer? And it's really valuable to have one throat to choke.
I agree with that. I agree with that 100%. And Adam, A-Team Adam, he says, stupid question, which is not a stupid question. Is TEC affiliated with blower door, Minneapolis blower door? Sorry.
Oh, yeah.
And,
so
yes.
TEC, or the Energy Conservatory, is the manufacturer of the Minneapolis blower door. So we've kind of, some people know us by the name of the product, other people know us by the name of the company. But yeah, it's one and the same.
Yeah, that had me confused before too. But yeah, totally. I was so confused. I'm going to scroll back here real fast. There was a couple other questions that I just want to make sure I didn't skip over. Adam says the middle is your expansion tank, where we're talking about the middle where it's neutral.
Yeah.
Yeah, that's cool. That's everything there. So Minneapolis, is it blower door only or duct blasting too? Just blower door.
The name, you mean?
No. Do you offer both? Do you offer okay.
Yeah. In fact, there's kind of an interesting story about where the Minneapolis duct blaster came from. Okay. So our first product was the blower door, and that's, I think, early 80s is when that came out. And it grew, slowly year over year. There's always been more and more interest. But the Minneapolis duct blaster is an interesting story. That actually came out of some research that was done with the Florida Solar Energy Center. And some people that worked there were curious and said, we don't know how big a problem this is. And Gary Nelson, our founder, was involved working with them. And they said, can you figure out a way for us to actually measure how much leakage there is in a duct system? And Gary thought, well, sure, it's just like a blower door, only smaller. Mm-hmm. And, working with them, they came up with this device. And the funny story is about the first prototype that was sent out. Gary did some research. And if you look at the AMCA standards for duct tightness, there's like 3 levels of tightness. And Gary said, well, we probably want to go with the leakiest. And I can't remember if there's A, B, or C, and I can't remember which one's the leakiest. But Gary said, okay, typical, big size house with this many square feet is going to have that many square feet of duct work. That's how the AMCA standard works, is by square feet of duct work. And we'll pick the leakiest. And then I better double that just to be sure. So that's how much airflow he figured he needed to test the duct work. And he sent out a couple of prototypes, and the people testing him called him back and said, this thing doesn't work at all, Gary. It won't pressurize at all. And the problem was because the ductwork was so leaky that it was it was more than double the leakage in the AMCA standard. It was like 5, 6, 7, 10 times as much leakage as the leakiest tier of the AMCA standard. And so he figured out very quickly that the problem was that we need a much bigger fan.
That's funny. I mean, that is wild. I mean, it doesn't surprise me, not even the slightest bit. Yeah. The duct systems that I see in attics, and like if your roof line is spray foamed and you're losing air in that, I mean, it's still not great because that's not a place you live in and everything else. But just imagine if it's just going straight out of the house and all of that air conditioning that you're paying, the air that you're paying to condition is just, you're basically like my mom always said, don't shut the front door. You ain't trying to cool off the world. And basically that's exactly what you're doing with leaking ductwork, is you're cooling off the world,
Yeah. And that research found out that of the air that's going through, that evaporator coil, anywhere from 20 to 40% of it very frequently is not even getting into the house. It's just leaking out the ductwork out the attic vents. Yeah.
That's so crazy. And the thing that most people don't think about is the fact that if it's leaking out inside of the attic and your attic's not part of your conditioned space, then that means you're basically negatively pressurizing your house. So now every crook and cranny, you got air coming in that's unfiltered, humid, not conditioned air, and now it's all coming right into your house. And so it's wild how much you're really throwing money away whenever you're not paying attention to your duct system.
And it's not just not just the money that's lost. Like you said, if you're blowing air out the attic, then you're sucking air in through the house.
Mm-hmm.
And what happens when that outside air hits cool sheetrock?
Right. I mean, it can condense, and
it condenses, and so you look in that closet or the back of that bedroom, and it's all full of mold. That's one of the main reasons, is because you're depressurizing the house, and you're sucking hot, humid air and touching cold surfaces.
So, is it a good idea, in your opinion, to take like I don't know, like a 6-inch booster fan and just have a vent that pulls air from like an attic eave or something like that, and just put it straight into a filter and filter it through the house to kind of make it positively pressured?
Yeah. So if I think that I've heard that called a scuttle. I've heard it called different names, but yeah, one of the ways that you can add mechanical ventilation is just to put a duct from outdoors into the return duct. And because that's sucking outdoor air into the return, as long as you get more leakage on the return side than on the supply side, you can end up having a positive pressure, or at least you might get back to neutral.
Yeah, right.
Which is better than negatively pressured. So yeah, that's one strategy, but obviously it's much better to just seal up the ducts.
Right. So what do you
because
think?
if the house is leaky, you probably don't need mechanical ventilation yet.
Okay.
That typically the experts say that once you get below about 3 ACH 50, and if you look at blower door standards, that's pretty tight. To get below 3 ACH 50, and really only below that do you need to add mechanical ventilation.
Okay. That was going to be one of my questions, is how, because I've heard of people complaining that they didn't want their house too tight, because you're talking about spray foaming walls and putting it on a slab, and then spray foaming the roof line. And then all of a sudden they're fearful that you're going to start growing stuff in the house because it's so tight. You don't have any fresh air coming in.
Yeah. So that's a common misconception, that, the house needs to breathe, and the house doesn't need to breathe, but the people do. And so
that's kind of important.
Yeah. And so once you get down to a certain air tightness, you need to add mechanical ventilation. And there's ERVs, the scuttle system we mentioned. Up in the dry climates or the colder climates, you can actually just use a bathroom exhaust fan that runs constantly. It creates a slight negative pressure on the house or on part of the house, and that provides adequate ventilation.
So that's perfect, because I was getting ready to ask about that, between the bathroom fans and like your hood on your stove. Is it good or bad to leave those running constantly?
Well, it doesn't normally depressurize the house because it's not enough flow, but it moves that neutral pressure plane up. So you get a little more of the house at negative pressure than you would otherwise. And so that is a common method of ventilating a house in certain climates. I don't think it's recommended in the hot, humid South, but if you're in the Western states, if you're in the northern part of the country, that's a common way that ventilation is done.
Let's see here. Chris Hughes, he asked, judging by national average of utility costs, what does a CFM run in savings as far as tangible dollars, as when you capture a CFM from air sealing?
That's a really good question that I don't know the answer to.
Good job, Chris. Good job.
Yeah. What I can tell you is that a CFM of air sealing in cold climates is worth more than in the South, and that's one of the reasons that the building codes say you need to be new construction has to be 3 ACH 50 or tighter in the northern states, but only 5 ACH 50 or tighter in the southern states. And that's because if there's less temperature difference between indoors and out, then there's less energy to be saved.
Okay. Makes sense. Let's see. Doug Crawl. Hey, buddy, by the way. Hey,
Doug.
I think he means inline. Do inline duct fans increase airflow to vents?
They do. but at the expense of what? You're going to, because a fan can only create a pressure difference. It can't create, if you put it in the duct, it's going to decrease the pressure on one side and increase the pressure on the other side. So it's robbing
Peter to pay Paul.
Yeah, you're robbing from other parts of the house. And in some cases that might work, but you better have a flow hood to know what you're doing.
Come on, now it's like my handometer. That's the flow hood I use. So
yeah.
Now, do y'all have a flow hood that you offer?
So we have had a flow hood. The Flow Blaster was available for quite a few years, and it was basically a duct blaster with a hood on it. We canceled that in, I think, 2017 because we had trouble with the battery pack. And so we looked at, can we just fix the battery pack? And what we decided is, no, we're starting over. So we're continuing to work on that. We don't have a release date to announce or anything, but you'll see a flow hood from the Energy Conservatory before long.
Okay, so and Doug wanted to make sure that he clarified that he was asking for a friend. So the grid, the airflow tester that you have, that goes into the
digital true flow.
So it's the digital true flow, and then does it only go in the little factory 1-inch slot? Because I think there's some of them that don't have that. No,
it's designed to go in pretty much any filter grill or any filter slot, regardless of the depth. So it comes with adapter plates that will adapt to most any filter size. And so you can, you just take the filter out, pick the right size adapter. And basically the adapters are the same as filter sizes. So you got a 20 by 20, we got 20 by 20 adapter. You got a 16 by 25 adapter. We've got an adapter for that. You just snap the grid into the adapter so that it fills up the extra space where the TrueFlow grid is not.
Okay, so tell me what you think about this scenario. What happens if it's like an open return?
Open return.
Straight open return, like sitting on a platform, and they just have it fresh pulling in. You just got the blank
with just a filter on the side of the cabinet, you mean?
Yeah,
that works too.
Sticking it right there on that.
Yeah, as long as we know the size of that filter that's on the side of the cabinet, you would do the sizing just the same. Where in fact that's what the setup we had in Orlando. So and you just you get the adapter that's the same size as the filter. You take your measurements with the filter, and then you swap it out for the TrueFlow and measure again. Good to go.
Okay, so what happens if I'm a service tech and I'm on site, and like, how do I know which adapters? I just buy the whole package of adapters that you have, or
we're still in the process of making sure we get that exactly right. The thinking right now is we're going to ask you to give us 4 filter sizes that are most common in your region. Okay. We know that varies a lot region to region, but you can certainly get more than 4 if you need more than 4. We haven't even decided what all the adapter sizes that we will offer are. We've got a core of about 8 or 10 that we think are the most common, and we'll just be listening to what customers are telling us about what they need.
Okay, cool. So I want to wrap things up here, but Adam has another question. Will the TEC flow hood be comparable to Dwyer and Alnor?
Okay, so the Dwyer flow hood is really only intended for 2-foot by 2-foot commercial stuff. Okay. Ours is going to be sized for residential.
Okay.
And the Alnor, they make both. They make one that's smaller size that works pretty well on residential. They make a bigger one. Well, like I said, ours is going to be focused on residential.
Okay, so to answer your question, Adam, it will be good. I mean, it will be like that one, but it's just going to be better. So
yeah, it's going to be good.
No, oh, cool.
I can't
Steve.
divulge too much, but we got some good stuff cooking.
If I'm a business owner and I'm listening to this, and what do I need to go out right now and purchase? Say I'm not measuring anything at all. My guys are like handometering it, and we're just hoping for the best. At the very best right now, we're using like the field piece dual port manometer. Like that's it. So
I think a really good first step is just the DG8 manometer.
okay.
And that's because you can use it to do the same static pressures you've been doing, but now you got a manometer that's good enough to do building pressures. What you need to know is that the standard manometers that technicians use are not good enough to measure a few pascals. Hang on a second here.
Oh, you're good.
Yeah. Standard manometers aren't good enough to measure a few pascals of depressurization or pressurization in the house or in the room.
Mm-hmm.
And so this will allow you to start understanding what's happening with the building pressures.
Mm-hmm.
I think the next step is probably the true flow. Once you know how to do building pressures and getting a little bit of insight there, now let's look at the true flow. I mean, if you listen to everything that Jim Bergman and Brian Orr and everybody says, it's airflow, airflow, airflow.
Absolutely. Absolutely. And not only that, one of the things that Joel mentioned whenever we were talking about stuff, and he kind of like did this aha moment for me, and that was the true flow on every comfort specialist or salesperson's van or truck, because every time they do one, they should be putting it in there and checking it.
Yeah, we've heard that from several different people. I mean, I think Joel mentioned that. Jim Bergman mentioned that when we sent him one to try out. He said, I would have one of these on every salesperson's van. And here's why. He said, when they go to sell the job, if you're a good company that's doing your sizing right, you're probably going to downsize that 4-ton to a 3-ton, but you still don't know if the ductwork is going to be big enough for the 3-ton.
Right.
True flow can tell you that, because if you know the static pressure and the airflow accurately, now you can calculate, okay, when we downsize from 1600 CFM down to 1200 CFM, what will the static pressure be? And we can give you that with good accuracy if we know static pressure and airflow.
That's really cool. And also one of the things that I think it was Joel that mentioned this too. He was saying that you could put the true flow in and then take your good flow hood and you go around to all the vents. And if they're not adding up to the same thing, then that difference is going to be your duct leakage that you know, like without a fact, without a concern or anything.
Yeah, you have to have a good flow hood to do that. The less accurate ones are not good enough to tell you duct leakage, because you're subtracting
so
one.
Is not going to work there.
Yeah, but the handometer is not going to work, and the cheap flow hood's not going to work either. But and that actually gives you a little different measurement than a duct blaster does, because it's measuring at operating conditions.
I like
explain that one.
Yeah, go ahead. Explain.
Okay. So
I totally grasp exactly what you're saying, but I could see people not understanding that.
Yeah, a duct blaster is designed to test the duct work and see if it's airtight enough to meet a standard. And when you do that, you mask off all the supplies and all the returns, and then you pressurize it to 25 pascals, is about 0.1 inches of water. So that gives you a leakage when the whole duct system is at the same pressure. But when you're operating, you get the highest pressure at the cabinet and lowest pressure down at the far end near the supply registers. And so depending on where your leaks are and how your pressure in your system compares to 1/10 of an inch of water, you might be higher, you might be lower. You'll get a different leakage number by doing that. So when you compare the flow through the air handler to the total flow out all the registers, that's actually telling you how much you're leaking under operating conditions, whereas the duct blaster is telling you how much you're leaking under a standard condition of 1/10 of an inch of water pressure in the whole duct system.
So would you say that doing it that way might be better for real world scenario?
Yeah, a duct blaster test is normally used to meet building code. You got to, they'll have a standard of how many CFM you can leak at 1/10 of an inch of water. And that's done because it's very reliable and it's very accurate for doing that. And, if you can pass the duct blaster test, you're good.
Yeah. Cool, Steve. Thank you so much for coming on the show and sharing your knowledge with all the other business owners that may be paying attention here. Is there anything that I forgot to mention? And also, where can people learn more about you and the Energy Conservatory?
So the place I would direct you for our most recent stuff is hvacAirflow.com. So you can also find that on the training section of our website. Energyconservatory.com is our website, but specifically HVACairflow.com is the newest training about measuring total system airflow, and you're going to see more and more content showing up there.
Yeah, that's awesome, because I really, to ask questions like this, obviously I'm flabbergasted that you'd be willing to come on a show, and I'm definitely honored to be able to ask you these questions for sure.
The pleasure is mine, Tersh.
But to have, for somebody that didn't meet you at the HVAC symposium, that has questions about that kind of stuff. I love the fact that you have HVACairflow.com to answer some of those questions, because even after you told me the last time we were talking about that and I started skimming on there, I was like, ooh, this is some cool stuff. I think it was, who was it? It was, what's his name that was there with you that mentioned, Bill, that mentioned about the buildings, the multi-story buildings. I don't even remember. Neither here nor there. But it was a really cool story that was on that. And he was like, yeah, just look it up. It's on the HVACairflow.com. And I was like, oh, okay, I'll definitely check it out.
Yeah.
And so I was pleasantly surprised with all of the data and information that was available to me on that website.
Yeah. Well, I appreciate your having me, Tersh. This has been a lot of fun. It's been a pleasure to get to know you a little better, to hear the community that you're connected with, and I appreciate your willingness to have me and listen to what I hopefully can contribute to the industry.
Absolutely. And for anybody that has any questions, HVACairflow.com. You learn more about the Energy Conservatory and Steve Rogers just there. And then if you have any questions for me, as always, Tersh at ServiceEmperor.com, or connect with me on Facebook, Instagram, LinkedIn, all of the social media.
You can reach out to me, if you got just general tech support questions. We got great tech support people. Just look at a phone number on energyconservatory.com. If you want to email me directly, srogers@energyconservatory.com as well.
Cool. And I will have all of that information in the show notes as well. So I hope you have a wonderful day. Thank you for listening to or watching the Service Business Mastery podcast focused on service business owners, managers, and technicians who are considering becoming business owners themselves. Until we talk again next week, have a wonderful and safe week.